Hey 42, today is another day. We trying to debug a multi-file program. So in the previous video we did on single file debug, it was factorial function. Today we're gonna do a multi-file program, which I'm gonna take a get next line as an example. So today our goal is to understand how we can debug a multi-file program. Well, actually, it's not that difficult. You just have to do some tweak to make it work. Another goal of this today's tutorial would be trying to understand probably the basic algorithm of get next line, and I'm gonna show how you can use debugger to understand your code better. Okay, so why use debugger? For me, I feel like our brain just does not have a lot of capacity sometimes. I mean, all the time actually. We just have a very limited RAM. We have a very limited working memory. So when it comes to understanding the how codes work, or maybe how some complex function works, is that your brain just couldn't hold a lot of information at once. Okay, it's almost like you're trying to ask someone to you know calculate some math for you. If I keep giving, let's say I keep giving you the number to multiply, to plus, to minus, at some point you just couldn't keep up with it. So this is true for programming as well. As you go through a lot of lines of code, you got lost. Okay, you're gonna keep track of where the data, I mean the number, or the variable is going to is going on. So what we can do here is we want to use debugger as a way to enhance our understanding on codes that you probably get from the reference on the internet. So to be honest, this code is not written by myself, so I've taken some working codes, and what I want to do is I want to show you how I will approach this when a reference code is given to me. Okay, as I'm trying to understand what is the general working of this code. So here we go. We got this directory inside with the getX line codes, from somewhere on the GitHub. So the next thing is I'm gonna create a main file basically. Sometimes you could actually also create this main file in this main function file. Okay, but I'm gonna try to create a main file here so that I can show you how we can compile it together with other source file. All right, so to debug this, the very first action that you probably want to do is to set a breakpoint. So you want to check the behavior of the code starting this line of code, and you put a breakpoint there. And next thing immediately is you can press F5 to start the debugging. So if you have not configured your task JSON and also the launch JSON, it will prompt you this selection here. So if you're on LibSL, so you can just click on the first selection. And the next thing that I would advise you to do is select GCC instead of Clang. Okay, because if you have Clang, don't choose that for LibSL. There's some issue with the LLDB. So I would advise you to just choose GCC. So we're going to choose GCC. Okay, now we get an error. The reason has to do with the launch JSON. So let's click this again, and also your task JSON. let's click this again. C. All right. So now we got both launch and task. Okay, these are two important file in debugging. First we go to the task first. Okay. Oi. Okay. For some reason, I got two task file here. We can ignore this one. Basically, they are both the same. So let me just delete this. Okay. Oops. Oh. Okay. Okay, I should delete this one. All right. So looking at this argument, basically this is what happened is when you execute the task, the task will actually call GCC, and after that it's gonna put in this argument in. So with this diagnostic color always -g, this is for debugging information. You will need to put -g if you would like to know if you would like to debug it, or else you wouldn't be able to debug it because it does not, the executable does not include the debugging information. So -g always. And this is the file, the currently or active file. Let's say you are opening this one, you're looking at this. When you execute that build task, basically you will build this main. Okay, so this is the problem. It only has main.c, so it does not compile with other source file which you are supposed to compile with, including the get next line and also get next line utilities. So what you need to do is you need to include those file. So to include that, you just put double colon. Okay. Oh, okay. I know why. I accidentally changed the input to pinging. That's why I couldn't understand what the double colon. Sorry, it's not double colon, the quotation symbol. So we have to include this one, and also utilities. Tools. Okay. Now let's check our launch here. So our launch would actually look for an executable. So right now there's no executable, okay? But what this launch cleverly do is it actually includes this pre-launch. So what happens is every time you launch it, it will actually go to this this task JSON and execute this code. So it will compile for you every time you try to debug it. Okay. So if you command this out or just get rid of this, then it wouldn't do that. Okay. So I think everything is well set up. Just go to main. Remember, you have to go to main. If you go here, if I press F5, there will be an error. Don't get panicked. Just go back to this one, and there you go. Okay, we are able to debug it. It runs successfully. Okay. But I'm not gonna use G's. Sorry, I'm not gonna use the GDB. Instead, I'm gonna use LLDB. So for LLDB, what you need to do is you could add an configuration here. So let me go to LLDB, go to launch. Okay. Now what you do on the program, just have to copy this thing. This is for the GDB. If you would like to use GDB, you can use this one. You just paste it over there. And if you would like to have a pre-launch as well, so where it will automatically compile for you, you could include this as well. You have to include it within this. Okay, so oh, okay. So you go back to your function. What you have to do is just select the launch. So now if you can change the name actually, just change this name to LLDB. And I'm gonna change this name. Okay, I'm gonna put a GCC then. View and debug file. Okay, so now I'm gonna execute it, and it's working. Okay. All right. So now we have a breakpoint here. So the execution stop at this line, and what we can do is we want to explore what the get next line does. So here we can just go to the next line. You can take a step over. So it's actually F10. You can press F10 on the keyboard. Okay, up to this point, if you press F10, it's gonna go to the printf. But if you would like to know what does the get next line does, you can press F11 as step into. So we're gonna step into. Okay, and looking at that, the FD now is actually 3. This is after we have. Okay, you can actually go to the call stack to go back to the previous function. So at this point, the FD1 is actually 3. Yeah, that means the file has been successfully opened. Okay, so here you will run this get next line code here. It does the checking. We can skip this if you have understood that. Okay, this is an interesting function that if you look at a header file, so there are several functions that we don't understand. The first, I mean the one on the 22 line 22, 23, and also 27, 28. So these are the code that we don't quite understand if you are still new to the get next line. Other than that, if you have done libft, you probably know about string char and string join and this. Okay, so we are interested in trying to understand this code that we still have no idea with. Okay, so I can press Shift, Control, and D, go to the debug control here. Okay, and press this one. Okay, now we are on this function. I would like to know what's this. Okay, let's say you want to know what is the left string is. Okay, and as you look at the local here, you don't see it. Okay, now there are a few ways that you can try to evaluate this value here. One way is you can go to the debug console. Okay, this debug console is really good, as I mentioned in the previous video. It allows you to evaluate a lot of things. Okay, in this case, I can even evaluate what is the left string is. So I can put print and left string. Press tab to autofill it. So because it is 0, 0, 0, 0, that's actually a null value. What else we can do? We can actually inspect the address of it. So you can put this ampersand and you put left string. Left a string. Okay, let's see. Yeah, so this is a memory address of it. It is at a very, very low address. Okay, now if you look at this one, is it on a higher address? Okay, I think, let's say, just being curious here. Let's say I put a, I'm trying to figure out what's the address of the line. I think this is on a higher memory address. Yeah. This has to do with the idea of how, you know, a program work, like in terms of the memory. So we basically have this stack on the top, I guess, and then you have the heap stack and heap, and then you have those like data segment, okay, where you store the your code, you store the variable, like this kind of variable, or static variable. So that probably explain why they are on a different location. This location, I think, is, they're so far away from each other. Yeah, this is like over FFF. This is like on a higher memory address. So usually if you put things together, the local variable, they tend to stay pretty close to each other. Okay, so I haven't completely understood how things work yet, but this is what I learned. They are being put on a different segment of the memory. Okay, so this will be helpful as you try to understand how program work, or maybe how the memory is being allocated to the variable. I find this to be super useful because I can look at the address. So what I want to point out is that in a watch list, sometimes you can also use watch list. Sometimes it doesn't work. Like, let me put this. See, it's actually invalid syntax, and I really have no idea how I can check the address. So it was a bit frustrating to me back then when I, trying to look at the address of the variable. Not until I discovered it in debug console. This is it's just so good. It's amazing to me that I'm able to see the debug console, I mean the address now. Even if I want to check on the register, I could do that as well. It's fantastic. Okay, so let's get back to this. Now we're trying to understand this code, so we can step into that. Okay, now it brings us to this function. All right, we got this malloc, and if you understood it, you can just skip this one. Okay, and we got this function as well. You probably have already noticed, so you can also skip this. So to skip this, you just press F10 as step over. Okay, and you realize that if you notice this part, the value changes as you execute the code, right? So for this one, the read bytes, okay, it's gonna read like 776. Oh, by the way, just now when I talk about this left string as a static variable, you can check it over here, but there's one place you can also check it, is this one, is on the global. Okay, so this is where the value resides at. Okay, it's actually on the global. Yeah. Interestingly, it's not on the static. So I'm not sure what is this actually, but yeah, it's actually over here. Okay, so getting back to this function, so you can execute this and try and understand. Now, sometimes if you want to make some notes, I suggest you just to put a command here on the same line. Because if it's not on the same line, let's say to put it over here, like blah blah blah, you have some issue that you have to either recompile it or a second. Oh, okay. So the thing is, if you put it on another line, like you expand the line, you insert a line, this highlight will actually point to the wrong line, because you haven't really done the recompilation. So you're using a old executable, but since you have changed the code in this source file, right? This debugger hasn't like realized the differences, so it will be highlighting on the wrong line actually. So what I suggest is, just put a very short command on the right side of that function or something like that. Okay, so let's say, just make a quick note like that. Just say assign read bytes from read function. Yeah, I advise you to put it on the same line so that you don't mess up with the flow of that highlights. What I mean highlights is this thing. Yeah. Okay, so now it has completed this this function. To go to the next one. So if this is for checking again, and we have another thing. This is another algorithm. So again, you can actually now if you have understood this one, basically it reads the file from fd and stop when the new line is encountered, or the EOF is encountered. Okay, what does it return? Okay, return a, this is a left string, so left string is this one. So it actually stored the left string. So it return the red string. Yeah. Okay. And then we have another function is get new line. So you can step into to see what happens here. Okay. Again, checking for this if it's null. So wow. Well, it's not so this is basically, I mean, you have red attacks like this test. Yeah. So let's say you have read some tags. Let's say your read function has read until here. Okay. So it has exceeded the new line. Okay. So what it does is it will move that, you could say, the pointer to where the new line at. Okay. So you're basically counting like the number of characters up to the point where you encounter the new line, and it's gonna allocate a memory for that. Okay. So the next thing is you're gonna copy the tags from, sorry, so you're gonna copy the previous tags, the previous the string up to this point, to a newly allocated memory. Okay. Which is at this line. Yeah, there you go. This is like counting the the left string. Sometimes this is too long, right? So what you can do is go to debug console. You can print left string. Okay, so these are the text actually. Yeah, this is in fact the whole text. If you go here, yeah, it actually read the whole thing. The reason is because the buffer size that is set on the header, it is 1000, so it's big enough to read the whole thing. But if let's say you put 10 or 50, it's gonna read like, you know, based on the buffer size, like 10 10 10. Yeah, it's gonna be a slower process, so you have a lot of looping going on trying to read the text. Okay, so yeah, so it's gonna read this text until it encounter this thing. So this thing is gonna have like gonna loop for many times because there are so many texts here. So now we have an issue here. So what we can do, if you want to skip this, you can just set a breakpoint after that. So you can press continue, so you skip that process. As you can see, there are 110 characters before that new line. Yeah, so you can actually utilize the breakpoint in this way. And then we go to the next function, and here what I'm trying to do, the left string I and left string is not equal to okay, in this step we are trying to copy that the last string to the string. Yeah, so string is a newly allocated like memories on a heap, so we're trying to copy what is on the left string. So this is left string, right? Copy everything here into that into the string. So if you'd like to see this work in the real time, you can press next, step into, or step, you know, sorry, this is you can press either step over and step into. Either one will work. So this thing is getting copied, and again, this is gonna loop for like 110 times. You can see that this string, right, is growing in size. Well, it already has a fixed size basically, just that you don't see the text yet. Okay, now if you are curious about the value of the string that is like after this, right, you can do something like this. Again, you can just go to print and then put string and put an index. Like say you're, you know, the number that has been allocated to the string, it was about 112. Just now we saw 110 for the I value, so it should be 112. So we can look at, let's say I want to look at the address at, you know, probably let's say 100. You can actually check that. So it's actually 0. I'm not sure other value. I think sometimes it has some garbage value. So yeah, what's interesting is you can, you know, play around with it. So you can even typecast it to in. So if you typecast it to in, instead of 1 byte being read, there'll be 4 bytes. So in this case, 50 is actually 400. So that is actually more than the memory that has been allocated. So interestingly, even that, I still get a 0. We have actually read, we actually exceeded the bound of the allocated memory. So we're actually accessing a memory that is outside of the allocated segment. I don't know if you put 100. What about 1000? Okay, we can still access it. Okay, that's interesting. All right, now we got some problem. Couldn't read it. This is stupid. Supposed to interpret but fail. So there are a lot of things to discover here, which you don't, you're not able to do it over here, right? So again, we are, looping over here, and you hate a loop. You can exit the loop by pressing this breakpoint to this line and just press continue. So you're now here. If this thing is equal to this, what happened is okay, so in this time you have to take some time to understand what this code is trying to do. So last string I, right? So you wonder what is last string I don't know what is this. We're gonna use debug console. So P and paste that thing, press that. Oh, now we are able to evaluate that this is actually a next line. Sorry, it's a new line. So the miss is gonna ask you this. Okay, now if you just curious about what's prior to the I, you can put I minus 1, and it's gonna be a dot, right? So basically we're looking at this section here. We're looking at this character, right? I is a number that is up to the new line. I'm gonna put I plus plus. You might wonder why you do that. So okay, the reason it does that is because it wants to be now terminated. It wants the string to be now terminated. Okay, so if it's not now terminated, basically the reader does not know where to stop. It will just continue reading it, right? Or maybe printf just doesn't know where to stop printing it. So it's important to have this now terminator. All right, we're done with that. So now you get a better idea what a function does. But then you kind of forget what does it do. So what you can do is you can go to right click this, and you can actually pick the definition. So when you pick the definition, it will overlay a segment over here. I'm trying to show you what this code is doing. So this one I also use a lot sometimes. So you can actually look at this just to get a better idea what this function is trying to do. If you would like to have the whole page, then just go to definition. Oops. No, go to reference. Okay. It's interesting. It is just the functionality is almost the same. Oh, I know, because this is on the same file. That's why. Is that the reason? No, it's not. Is it? FD new line. Okay. Well, I was expecting that it's gonna show you another page of the FD get line. So, but it seems like everything I do here is gonna have an overlay. Yeah. So if you would like to know the whole page, if you would like to open it in the whole page, just press Control and click on this. Hey, no, sorry. Is it double click? Anyway, I kind of forget what to press. Yeah, you'll be able to open it. Like, you can try to find that out. So now we lost track. Don't worry, you can go back to call stack and press the function here. So we're back to this. And go to the next one. And if you'd like to know, again, you can do the same thing. Just step into it and and try to understand the code. Put a command there in case you forget, you know. I think it's a good practice to put a command to mark down what the function does. Let's say you already know this function, so you can actually press step out. So Shift F11 is going to be the shortcut key for that. So we're going to step up and next and so on. Okay, so now line has this thing. It's too long. Utilize the debug console. So print line. There you go. This is the line that's supposed to be printed. It even include the address. Yeah. So yeah, that's all for today then. This is for the multi-file program debugging. I hope this doesn't bore you. I'm talking in a very slow manner, I guess. This is how I always talk. I hope it doesn't make you feel drowsy. If you feel drowsy, so please bear with me. I'm still new. I'm trying to learn. So I hope you learned something today. And thank you. I'll see you again. Bye-bye.